All right. Assignment 20, AB number 9, multiple choice. Now we're kind of getting close to wrapping things up, all review. So this is just kind of a bonus one. It's not really covering specific ideas, just kind of a little bit of everything. So you should try it ahead of time. You should have tried all the problems. And then I'm going to go ahead and just go through all of them right now. But you should have tried them. If you're having to wait for me to do the problems, you should be very worried about your AP test. But you should be able to do them on your own. Okay. So 50th derivative of cosine. Well, probably don't want to have to do 50 derivatives, but might be good to kind of look for a pattern. So first derivative is negative sine x. Second derivative is negative cosine x. Third derivative is positive sine x. Fourth derivative is positive cosine x. And now it's going to just repeat itself. So there's this group of 4, and then they just keep repeating themselves over and over again. So the idea here is to divide all the groups of 4 out, because every group of 4, you're back to the start. And then look at the remainder. The remainder is what you want, because the 50th derivative is equal to the second derivative, which is negative cosine x. Now, if you get a remainder of 0, this is the 0th derivative of the original function. So look for patterns. Number 2, what are the values of x for which this function has a relative minimum? So I probably want to do a line check. You got to find the first derivative. 4x cubed minus 16x equals 0 or undefined will give you critical points. You want to factor it. You factor 4x out, then you have an x squared minus 4 left over equals 0. Undefined is not going to happen. And then you can factor it again or just solve that for its 2 answers. But there are all of these critical points. So then we do a line check, and we say -2, 0, 2. None of them are even roots, so we don't have to worry about it. Not changing sign. Test x equals 3. Positive, negative, negative. Down, up, right? Decreasing, increasing, decreasing, increasing. So here's a relative min. Here's a relative max. And here's a relative min. So we're looking for all the relative mins, the x values. So that's -2 and +2 only. All right. Okay, number 3, we're integrating absolute value. Got a couple ways to do it. It is a linear absolute value, so you could just draw a graph. The main thing is we're going to have to break it up. And so you have to break it up when the inside equals 3. So you're going to have to break it up 3. You can do a line check and say, okay, well, what's the function do on the inside? Test x equals 4, positive, negative. So you're going to, one way is to break this up and go 2 to 3 and get rid of the absolute values. That's sort of the point. And then do 3 to 4, get rid of the absolute values. And then the positive part just stays positive. The negative part you got to fix with an extra negative in front to force it to become positive. So then you can integrate each of those. But the other way is to just draw a graph of this, since it is just a line, and say, okay, well, 1, 2, 3, this is its x-intercept, and the slope is 1. So we're going up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. We're going 2 to 4. So, and then the negative part gets flipped upwards. That's what absolute values do. So that's the actual graph. And we're going 2 to 4. And so what you'll notice is 2 little triangles right here. So it's going to be 1/2 base times height. So one of them is 1/2. And then there's another one that's 1/2. So the answer is +1. Now, if you kept going with this other one, you would have got the same thing. But you get a -1/2 here because it's underneath, and that's why you need the extra negative to force it to become positive. Number 4, you should think, oh, wow, that's the definition of the derivative, right? I mean, it should make you think this is something special. So what is the function we're trying to take the absolute value of? X. And then what's the derivative of it? I don't know. And then what's the derivative of it at 3? Well, I don't know. Now, I don't want to really you can take the derivative of absolute value of X, but you got to write it as a piecewise function first. The quicker way is to just graph it and be like, well, this is what an absolute value function looks like, that one, right? And we want to know the slope of the graph at 3 right here. Well, the slope is 1, right? That'd be the fast way. So we're always looking for fast ways in multiple choice. Number 5, what is the value of b for which this function has a horizontal tangent and an inflection point at for the same value of x? So horizontal tangent, we got to take the derivative, 4x cubed plus 2bx plus 8 equals 0 is a horizontal tangent. Inflection point is going to be when the second derivative equals undefined or 0, potentially, as long as it's not a multiple even root. 12x squared plus 2b equals 0 undefined. So I'm pretty sure we're going with 0 down, because I don't think we're going to be able to plug a value. None of these b values are going to make that undefined. So we essentially have a system of equations now. What we could do is we could try and solve for one x in terms of b or b in terms of x. I think this one's the easier one to get b by itself, right? So b equals negative 6x squared. And then we're going to plug that in for b up here. So we're going to get 4x cubed plus 2 times negative 6x squared times x plus 8 equals 0. And now we can solve for x. Now, we're not looking for x. We're looking for b, but we're going to find x first and then plug it up here to find b. But I bet the x answer might be on here, which is a little messed up of them. 4 minus 12, that's negative 8x cubed equals negative 8. X cubed equals 1. X equals 1. And sure enough, it's there, but that's not the right answer. You want to find the b value, so you plug that back into our b expression, and we get negative 6. Little systems of equations. Number 6, what's the average value? So I'm assuming that means of just the function. And so mean value theorem, average f, you shouldn't memorize this. You should remember how to get it. We want to find the average value of this function, the average height of it. So we're going to smooth it out, and that is the average height. But when we smooth it out, the area underneath it is still the same area, right? But we smooth it out and we divide by the base, and that gives you the height of that rectangle, which is the smoothed out height, which is the average height. So this is going to be 2 over pi. Antiderivative sign is negative cosine, negative, right? 0 to pi over 2, 2 over pi, negative cosine of pi over 2 minus negative cosine of 0. So cosine of pi over 2 is 0, and cosine of 0 is 1, and it's negative, so it becomes positive. So the answer is 2 over pi. So some good quick tests of your basic, your knowledge of some of these basic functions. You should have tried them all. This is just to help you figure them out. If you got them wrong or whatever, you should check your answers before this too. Trying to find the derivative. Look at all the answers. They all have x's and y's in them. So we're going to try and do this implicitly, right? So we're going to take the derivative with respect to x. Derivative of x with respect to x is 1 plus dy dx equals, we got a product rule, x times derivative of y is dy dx plus y times derivative of x is 1, and this is what we're trying to get by itself. Now, if we actually had to find like a value of it, I just plug in the x, y numbers now and then solve for dy dx. Probably easier, but we're actually trying to get these expressions here. So we want to get the dy dx's on the same side and factor the dy dx out and get all the other stuff on the other side. Then divide both sides by that. So you get y minus 1 over 1 minus x. And this looks close, but it's not right. That's the closest one, but it has x minus 1, so 1 minus x. You should consider that you might need to multiply the top and bottom by a negative, and then it would look like this, 1 minus y over x minus 1. So sometimes you have to manipulate your answers to see the right one. Number 8, for what values of x is the graph concave down? So we got to take the first derivative, 3x squared minus 12x, and take the second derivative, 6x minus 12, set it equal to 0 undefined, to find potential inflection points. Factor it. Undefined is not happening. So x equals 2 is an inflection point because it's raised to an even power. But a line check could help you just real quick figure out where it's concave up or down. Test the value, label your line check, x equals 3, positive, negative, so it's concave down, concave up. And this is an inflection point. So we wanted concave down, so that's going to be negative infinity to 2, and you do not include the endpoint, or x is less than 2 is the same thing. So there you go. Number 9, particle moves along the x-axis so that its position anytime t is given by this. So this is a one-dimensional motion, rectilinear motion. When is a particle moving to the left? Well, that would be when its velocity is negative. So we've got to find velocity, which is the derivative of position. So that's going to be 15 t to the 4th minus 75 t squared plus 60. And set it equals 0 because that's where it's going to change. Factor this if we can. We take a 15 out, and it's going to be t to the 4th minus 5t squared plus 4. Can we factor this more? Even though it's a quartic, it looks kind of like a quadratic trinomial. -1, -4, perfect. So t equals +1, -1, and t equals +2 and -2. And so then we can put these all on a line check real quick. -2, -1, 1, 2, in order left to right, smallest to biggest. Test the value. T equals 3. Everything's positive. There's no double roots. Even the squareds each gave you unique separate answers. So it should change. So moving to the left is going to be negative, right? So it's going to be -2 to -1 and 1 to 2. So -2 to -1 and 1 to 2. So that's going to be B. But see, this is tricky. We might also say no negative time, but they're not going to put answers in the list. If they say no negative time, they're not going to put that answer there. So a better answer would be that they would have said that t has to be greater than 0, and they wouldn't have put any of these negative answers. I'm pretty sure they wouldn't. And then you would have gone with just 1, 2. That would be the better answer. So, yeah. Anyways, that's it. Hope you're doing well on these problems. Try the assignment 20 free response problems now.